Hello my scholars, welcome to my school YouTube channel. My name is Emmanuel and in today's video we'll be tackling JAMB CBT past question chemistry the year 2007. Please don't go anywhere, stick around and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we'll be tackling question 1 to 25. Now let's get down to question number 1. Triazonitrate 5 acid is not used for preparing hydrogen gas from metals because it is what? Option A says strongly oxidizing, it's a volatile, it renders the metal passive, forms a layer of oxide on the metal. Actually, you should know that triazonitrate 5 acid, also known as nitric acid, that's HNO3, is a very strong oxidizing agent, and usually when the reason it's not used in preparing hydrogen gas is because it has the power to oxidize the hydrogen that is formed. So instead of hydrogen gas being formed, once it becomes oxidized, it forms water. So and it makes it difficult for hydrogen gas to be collected and prepared. So that is the reason it is not used. So it is because it is a strong oxidizing agent. Option A says strong oxidizing agent, volatile, rendered. So the correct answer here is option A, is strongly oxidizing. Now let's move on to question number 2. An element used in the production of matches is what? When we say production of matches, the head of the match, okay? Usually it is sulfur. The reason being that sulfur has the tendency to create fuel. It has an igniting power such that once it is used to hit a striking surface, okay, it ignites, okay? So option A says nitrogen. Nitrogen is used mostly in preservation of food, okay, to preserve it from decaying, from dehydrating, so as a preservative. Aluminium can be used maybe in the making of substances that are lightweighted, or maybe because it's light, okay, it can be used maybe in cables, can be used in making of aeroplane, okay, because of the lightness of the this and making of some containers, okay. Copper, usually we use that in electrical wiring, substances, okay. Maybe you want to make electric wiring, yes, we use copper in that. But for sulfur, of course, is a non-metal and it has a tendency to ignite, okay. Once you bring it, it has an igniting power such that it serves as fuel when you use it on a match. So that's why you see the match stick, okay. You have that color, what you have there is sulfur mixed together with some other elements to make that matches. So the correct answer here is option D, sulfur. Now let's move on to question number 3. When calcium oxide is heated with carbon, the oxide will be what? Don't forget there is a reaction here, there is heat that is applied to this, okay. So let's look at the board and see what we can have. Let's write the reaction. Calcium oxide reacting with carbon, of course there should be heat, it is heated, okay, because there's heat here, so we have we are going to have calcium carbide to be formed, okay, plus then we are going to have CO, of course, that's carbon 2 oxide, okay, or carbon monoxide. So let's see, calcium is 1 here, carbon is 2 here, carbon is 2 here, so here is 1, so we have 2 here, then oxygen is 1 here. Number of carbon here, we have this is 2, yes, this is 1, that's 3, okay, so number of carbon should be 3. So we have 3 carbon atom on the left, 2 plus 1, that's 3, then 1 oxygen, 1 mole of calcium, 1 mole of calcium. So we have a carbide, yes, of this calcium that is formed with carbon monoxide, so carbon 2 oxide. So we have option A says be converted to carbide, yes, because we had calcium carbide was formed. Option B, we have be converted to the triazocarbonate 4 salt. No, we don't have that there. Option C says decompose to the metal, and option D says melt, producing carbon 4 oxide. So the correct answer here is option A. The oxide will be converted to carbide. Now let's move on to question number 4. A solution which on treatment with hydrochloric acid produces a colorless, odorless gas which turns lime water milky is most likely to be a what? The first question we need to ask is that what gas, okay, is liberated that is colorless, what gas is odorless, and then what that same gas has the power to turn lime water milky, to turn it to a milky color. There's only one gas that can turn lime water into milky color, of course, that is colorless, that is odorless, and can turn lime water milky is carbon dioxide, which is carbon dioxide. CO2 has a tendency to change water milky. Of course, it's a confirmatory test in when we talk about the qualitative analysis, okay, to test for the presence of CO2, of carbonates. And where does CO2 comes from? CO2, that's carbon dioxide, usually would have come from a carbonate, okay? CO2 from CO3 2 minus. CO2 cannot come from triazonitrate, NO3 minus, okay? If we have this, we cannot have CO2 coming from this NO3 minus. We can't have it from chloride. There's no, we can have CO2 from here. This triazocarbonate 4, that is CO3 2 minus. Yes, we can have CO2 coming from here. Then we have hydroxide, OH minus. There's no, we can have a carbon dioxide or carbon dioxide coming from here, from here, from here. So this is eliminated, this is eliminated. So this is the correct answer. So a solution which on treatment with hydrochloric acid produces a colorless, odorless gas which turns lime water milky is most likely to be a triazocarbonate 4. So the correct answer is option C. Now on to question number 5. The soft solder used for welding and plumbing is alloy of what? When we talk about alloy is the substance that is formed, okay, or a compound that is formed is a mixture of two or more chemical elements combined together, okay. Most likely one of those elements or should be a metallic substance, okay, should be a metal, okay. So when we have two or more elements, chemical elements combining together to form a desirable property, okay, we say that is what? That is an alloy. And then we are talking about a soft solder. So if we are looking at, you know, a soft solder used for welding and plumbing, for it to be qualified to be used as welding and also for plumbing, that means that substance, of course, the alloy or the elements that will be used combination to form that mixture or the alloy must definitely have a low melting point. We talk about what we call eutectic alloy, okay, that kind of alloy that it's able to have low melting point when you apply it, and then it can be able to weld two or more, you know, metals together and then still have a low distance. It's what we call alloy. So option A says lead and tin. When you look at the two of them separately, they have high melting points, okay, but what we discover is that when you combine the two of them, lead and tin, they have that what we call the eutectic alloy. They tend to have a low melting point, okay, so it makes it easier for them to be able to weld two or more elements together. You look at this, we have iron and tin. Of course, the melting point of iron is actually so high, you know, compared to where we have lead and tin, okay. Option C, we have lead and tin. In fact, when we talk about elements that are light, okay, and that can be used, that has low melting point, that can be used in welding substances, okay, we talk about lead. Lead is, you know, one of the elements that is light, that can has tendency to what? To melt together, you know, you have this. So for this, we have iron here and we have iron here. So we can eliminate, if you are not sure, you can eliminate option B and option D because of the presence of what? Iron that we have here, okay. So we are left with option A and option C. We have lead and lead here. Then what we are considering is tin and zinc. This, of course, has tendency to what? To melt together. If you have this is heavier, we can have zinc also. But because of the reactivity of zinc, okay, together with lead, the combination might not be too fine to have it to have a soft, because we are talking of what? A soft solder, okay. If it is heavy, we can be talking of iron, can be talking of zinc, okay. So lead and tin actually is a good combination to have one, because when you combine the two of them, they tend to give us a low melting point, okay, and then it's able to what? To not just to weld metals together, but also to be used as plumbing what? As plumbing material. So option A, which is lead and tin, is the correct answer. The soft solder used for welding and plumbing is alloy of lead and tin. Option A is the correct answer. Question number 6. The reddish brown rust on iron roofing sheets consists of what? When we have a reddish brown rust on the iron roofing, it means that what? There has been rusting that's taking place. And when we talk about rust has a formula, okay. We call it, the other name we call rust is hydrated iron oxide, okay, hydrated iron 3 oxide. So if you look at what we have here, and then it has the formula this way, we have Fe2O3, okay, dot X H2O. X determined is just representing the number of moles of water that can get attached to this. Don't forget that for rusting to take place, there are two factors that are very important. Oxygen must be able to react, okay, to the iron, and then moisture content. When there is water, that's moisture and oxygen on the metal, of course iron, we say that rusting has taken place. That's what causes. Then you discover that the iron, the metallic, begin to turn into reddish brown, and then begins to have some substances around it because rusting has taken place. The only compound that makes that to happen is what? This hydrated iron. So if you look at all the options we have here, this is Fe3 plus H2O, this aqua, no, this is not. We have FeO H2O, no, we have that. We have Fe2O3 dot 3 H2O, yes, that fits into this. This is Fe3O4 dot H2O. So if you look at what we have here as the formula for rust, okay, we see that option C, Fe2O3. So for this one, we have 3 moles of water attached to it. So the correct answer is option C. Now let's move on to question number 7. We have a chemical reaction here. This is sodium thiosulfate. Then we have it reacting with 2 moles of hydrogen chloride or hydrochloric acid, yeah. Then with to form salts and water. Of course, you know that when we have, yes, this is not the only product we have. We can have SO2 also there, and then we have sulfur is also there. But these are the major products. So limiting ourselves with this reaction. The question says, which of the following would introduce the greatest increase in the rate of the chemical reaction above? Now, if you look at this reaction properly, this is an acid, this is a base, okay? A base reacting with an acid to form salts and water. You know that that is what? A neutralization reaction. And generally, all neutralization reactions are exothermic reaction. When we say exothermic reaction, a lot of it is being what? Evolved, okay? Is being given off from the system into the what? Into the environment. And for us to have an exothermic reaction, so it means that delta H is actually negative. So if delta H is negative, what happens? Option A says an increase in temperature and decrease in the concentration of the reactant. There cannot be an increase in temperature and then for us to have a decrease in the concentration of the reactant. If we do that, this reaction will not have the greatest increase in the chemical reaction, okay? Option B says a decrease in the volume and then increase in the pressure of the reactant. Of course, when we talk about pressure, increase the pressure of the reactant, we don't have any of this, whether it is the reactant or this, we don't have any one of them in gaseous form. When you talk about pressure, we're talking about the gaseous state of the reactant and then the reactant. So this also will not be. Option C says a decrease in the temperature and an increase in the concentration of the reactant. Increase, yes, a decrease in temperature. If we have to have more of this salt and water to be formed, okay? Now we said that this reaction, we said, is exothermic because it is a neutralization reaction. So if delta H is negative, okay, it has negative value. Now watch this, delta H, if delta H is positive, okay, increase in temperature will favor forward reaction, okay, while decrease in temperature will forward backward reaction. So vice versa now. For exothermic now, increase in temperature will forward the backward reaction, while the decrease in temperature will forward the what? The forward reaction. So that means to forward the forward reaction, this is a negative, delta H, because this is exothermic. If it's exothermic, it means that a decrease in temperature will favor the forward reaction because we are looking at where we want to have more of this form. So if delta H is negative, an increase in temperature will favor more of this. So which means that a decrease in the temperature, yes, will favor this. An increase in the concentration of the reactant react more in the concentration, increase the concentration of this reactant, we have more of this to be formed. So with that, option C is correct. Option D says an increase in temperature and an increase in, we cannot have an increase in temperature for this to happen because this is what? An exothermic reaction, okay? So based on that, the correct answer is option C. On to question 8 now. The tincture of iodine means iodine dissolved in. So whenever we want to have a treatment of wounds, okay, maybe for first aid, you know, usually we have what we call tincture of wound. Tincture of iodine, what it simply means is that iodine is dissolved in water and then in water. The mixture of ethanol and water, okay, just add iodine into it. So what it does is to help to heal the wound on time and then to disinfect, to prevent infection of what microorganisms to the surface of the wound. So that's when we have tincture of iodine. So tincture of iodine means that iodine is dissolved in water and ethanol. Option A says ethanol and water. Yes, that's correct. Bromine, chloride, no. Chlorine, water just itself, no. That would have just been diluted of that. So option A, which says ethanol and water, is the correct answer. Option A is the correct answer. Let's move on to question number 9. We have copper ion, copper 2 plus here reacting with ammonia to form this complex ion, okay? And then the question says, in the reaction above, what is the effect of precipitating copper ion as copper sulfide? Now, if you precipitate copper ion as copper sulfide, what it simply means is that what? We are going to have the concentration of this copper ion in this solution will begin to decrease. Okay, now once copper ion is precipitated as copper sulfide, the concentration of copper ion here will decrease, and once it decreases, what happens? It will, according to Le Chatelier's principle, it says that the equilibrium position will begin to shift to the side that is going to annul, that is going to affect or counteract the effect of the of the reduction in that copper ion density, and which means that it's going to tend towards this point. So in doing that, which means that more of the ammonia will be used up, okay, to produce what? This complex ion. Okay, when that is done, what happens? We discover that the equilibrium position definitely is going to shift to the side where we are going to have more of the copper ion to be recovered, okay, to have more of the concentration of the ion to be recovered, which is this point here where we have this complex ion. So which means the equilibrium position here is going to shift to the right, favoring what? The forward reaction, which is this. Option A says ammonia concentration will decrease, but don't forget we are talking about precipitating copper ion as copper sulfide. Okay, so we are going to have more of ammonia. Less of ammonia will be formed because this one will be used up. Okay, so option A is not the correct answer. Option B says more ammonia will be formed. We are not going to have more ammonia to be formed because this ammonia we have here will be used up, okay, and then it is more of this one that will be consumed, that will be used, that will be the concentration of the copper ion will decrease because we are precipitating copper ion as copper sulfide. Okay, so which means that this option B also is nullified, is eliminated. Option C says the equilibrium will shift to the right. Of course, definitely, because that is the point where the copper ion is going to increase, because since copper ion has been precipitated here as copper sulfide, so the copper ion here concentration will get reduced, will decrease. So once it decrease now, equilibrium position according to the Chlorine principle, we have to shift to the side where the copper ion is more, and then we'll be able to recover the change, effect of the change that has been caused, which is at this point, and this point is the right. So the equilibrium position will shift to the what? To the right, which is very correct. Option D says there will be no effect. Of course, there will be effect. So the correct answer is option C. Do you know you can take practice questions on our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to download the Myschool mobile app on your Android and the Myschool software on your laptops and computers. So please go ahead and start practicing. Now let's move on to question number 10. Copper and silver metals are commonly used as coin because they are what? Option A says easily reduced. Option B says not easily reduced. Option C says easily oxidized. Option D says not easily oxidized. We find out that copper and silver, actually they are metals that are used mostly as coin because they will not react with oxygen in the air. Yes, that is why you discover that they don't get rust, okay, even if it comes closer to maybe with water, and then it just like what the iron will do, okay, it will not die because this is copper and silver. So copper and silver are not easily oxidized. When we say they are not easily oxidized, when you react them, they come in contact with oxygen in the air, they are not easily oxidized, okay, and that is why you discover that the structure, okay, of that coin remains unchanged. Okay, it gives it that phase structure of the coin, because it will not get easily reduced when exposed to air. So option A says easily reduced, option B says not easily reduced, option C says easily oxidized, option D says not easily oxidized. Yes, copper and silver metals are commonly used as coins because they are not easily oxidized. The correct answer is option D. I hope you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video. Now let's move on to question number 11. Which of the following sets of metals dissolves in dilute HCl? Which of the following sets of metals dissolves in dilute HCl? Now, for any of these metals here to dissolve in dilute HCl, it means that, of course, the metals are usually positively charged, and then in this HCl we have hydrogen here positively charged while chlorine is negatively charged. So which means that any metal that is able to dissolve in dilute HCl has the power to displace hydrogen ion. So once it displaces hydrogen ion, then it can come in there to dissolve this HCl, to separate it. So if there's no one that has the power to separate these two because they are married to each other, so it's going to form, it needs something that is stronger, a metal that is stronger, that is more powerful than hydrogen, to be able to to withstand, and then to be able to separate these two. That's what it means by to dissolve. Okay, so now in this case, now what it means is that we have to look at the elements, any element that is above hydrogen in the electrochemical series, okay, in the reactive series, in the activity series, will be able to displace hydrogen. Then anyone that is below hydrogen definitely does not have power to separate these two, to dissolve it. So let's look at the options. We have option A says Fe, which is iron. Yes, iron is above hydrogen in the electrochemical series. Okay, then we have tin, and then we have copper. Of course, tin is also above hydrogen, so tin has the power to dissolve this, but copper here does not have the power because it is below hydrogen in the reactivity series. So because of this makes this option to be null. So we nullify that. Option A is nullified. We eliminate that. Option B says magnesium. Of course, magnesium is highly reactive metal than hydrogen, so it has the power to displace hydrogen from this HCl. The same thing, iron also has the power to displace. It is more reactive than hydrogen, so in the reactivity series it can displace this. But copper, here comes copper again, the same thing happens. So copper will not be. So let's just look at the options. Let's see the ones that have copper so that we don't waste our time. So we have copper here, we have copper here. So copper definitely is below hydrogen, so this is also eliminated. So we are left with option C. Now option C, magnesium, yes, is higher, is more reactive than hydrogen, so it can displace hydrogen. Tin, yes, tin is highly reactive, is more reactive than hydrogen, so it can displace hydrogen. Then we have iron is more reactive than hydrogen, so it can displace it. So because of that, magnesium, tin, and iron are the metals, sets of metals that can dissolve in HCl. So the correct answer is option C. Question number 12. If chlorine is bubbled into water and the resulting yellowish green solution is exposed to bright sunlight for a while, what happens? The solution will decompose, giving out what? Now what happens is that when chlorine, don't forget chlorine is Cl2, okay, is bubbled with water, what happens? The sunlight, because it's exposed to sunlight, the sunlight is going to break this chlorine, okay, chlorine molecule, Cl, we break the chlorine molecule. Once it breaks the chlorine molecule, then it will now liberate oxygen from the water that we have here, and then we have H and then the Cl. Let's look at the board to see the reaction. What happens there? We have this is chlorine molecule here reacting with water. It is dissolved in water. Don't forget, in sunlight, okay, in sunlight we have so the sunlight is going to break this now, so that we now have the hydrogen now comes in here to form HCl with it, and then we have oxygen definitely will be liberated. Let's balance our chemical equation. We have 2 hydrogen here, we have 2 here, so this is 2, then chlorine is 2 here, chlorine is 2 here, oxygen is 2 here, oxygen is 1 here. So we can have 2 here, we have 2 here, oxygen is 2, hydrogen is 4 here now. So which means hydrogen here will be 4, and then here will be 2. I think the question is balanced now. 2 times 2, that's 4. 4 chlorine here. We have 2 times 2, that's 4 hydrogen here. Oxygen is 2. Oxygen is 2. So we are going to have 4 moles of HCl, hydrochloric acid, and then oxygen will be formed in that reaction, because the sunlight here will break the bond between the chlorine molecule that we have here. So 1 chlorine molecule, then we have hydrogen here, the water here, the oxygen here, then will not be what? Will be liberated from here to have this. So let's look at the option. Option A says oxygen, the solution will decompose, giving out oxygen, yes, and leaving behind aqueous hydrochloric acid. Of course, that's what will form there. Option B says chlorine and oxygen, no. Oxygen, hydrogen, and chlorine, no. Option D says oxygen, thereby producing hypochlorous acid, no. The correct answer is option A. On to question 13. We have a chemical reaction here. Okay, you have that's the phosphate acid, that's phosphoric acid. Okay, we have H3PO4 here reacting with water, then to have this, and then we have this. Delta H here is negative 13 kilojoules at 298, that's standard temperature. So we have in the reaction above an increase in temperature would what? Increase in temperature. Now, in a chemical system in equilibrium, when we talk about effect of increase in temperature or decrease in temperature, what we usually consider is the value for the delta H. That's the enthalpy change. Okay, is it positive? Is it negative? If delta H is positive, it means it is an endothermic reaction, which means that more heat is absorbed into the system. Okay, and then if delta H is negative, it means it is what? Exothermic reaction. It is exothermic reaction. So I will just give us something now to look at. Let's look at the board that will help guide us when it comes to questions in that has to do with temperature. So whenever delta H is positive, it means it is endothermic reaction. So an increase, this shows increase, an increase in temperature, okay, will favor the forward reaction. Okay, when we say forward reaction, we are talking about what? The product. Okay, we are talking about the product. So which means more of the products will be formed if you increase the temperature for an endothermic reaction. Okay, it means that what? The forward reaction will be favored. And then if you decrease, this shows decrease. If you decrease the temperature, still for endothermic reaction, of course, this will favor the reverse. Now, the backward reaction. Okay, which is the what? The reverse reaction. So which means that more of the reactants will be what? Will be formed. Okay, the equilibrium position will shift to the left, favoring more of the reactant piece. Then if delta H, which is change in enthalpy, is what? Is negative. What happens? We have an increase in temperature for exothermic delta H. An increase in temperature will be the opposite of what happens here. Don't forget, when the temperature was increased there, the forward reaction was favored. But for this, when the temperature is increased here, it will favor the backward reaction. So it's just the opposite of what happened there. Okay, the backward reaction, which means more of the what? Reactants will be what? Will be formed. Okay, if temperature is increased for an exothermic reaction. But if the temperature is decreased, reduce the temperature, what happens? Of course, the opposite of what happens here will come to play. So the forward reaction will be what? Will be favored. Forward reaction will be favored, which means that the equilibrium will shift to the right. So more of the products definitely will be formed. So for an what? Exothermic reaction. Increase in temperature will favor the backward reaction. So that means the equilibrium position will shift to the left, favoring more of the reactant. But if the change in temperature, okay, is decreased, if there is a decrease in temperature, the forward reaction will be favored. The equilibrium position will shift to the right. More of the products will be formed. So with this, can guide you when it comes to answering questions under the effect of change in temperature in a chemical system in equilibrium. Just check, what is delta H? Is it positive or is it negative? If the value is positive, it's endothermic reaction, so follow through. If the delta H is negative, it's exothermic. From the reaction we're given, we discovered that delta H was actually negative 13 kilojoules. Okay, so which means that this is what? A negative. This is what? Exothermic reaction. Okay, and with what I just gave us there, if it's exothermic reaction, it means that an increase in temperature. The question says that in the reaction above, an increase in temperature would increase in temperature. So which means this now? Increase in temperature will favor what? The backward reaction. The backward reaction means what? More of the what? Reactants that we have will be formed. Of course, which is what? The reverse reaction. When we say backward reaction, we are talking about the reverse reaction because temperature is increased. Let's move to the screen and see what we have. Option A says slow down the reverse reaction. It's not going to slow down the reverse reaction because delta H, more heat is being what? Is being given off. Okay, more heat is being given off into the what? To the environment. So it's not going to, this reverse reaction is not going to be slowed down. Option B says have no effect on the reaction. Of course, it's going to have effect because we discovered that there's more heat that is given out. Because of that, there's going to be the equilibrium position has been altered. Okay, so the equilibrium position we need to now shift. The system will need to adjust according to Le Chatelier's principle in order to annul and cancel the effect of that changes that have been brought in by the change that has taken place in temperature. Option C says favor the reverse reaction. When we say favor reverse reaction, we are talking about the equilibrium shifting to the to the left. Okay, backward reaction, that's the reverse reaction, which means more of this will be for, of course, which was what we saw on the board, that an increase in temperature for an exothermic reaction, delta H being negative, will cause what? The equilibrium position to shift to the left, favoring that. So which means option C is correct. Option D says favor the forward reaction. The forward reaction will be favored if the temperature was decreased for an exothermic reaction. So the correct answer is option C, favor the reverse reaction. Let's move on to question number 14. The reaction that takes place in Daniel's cell is, of course, when we talk about cell, we are talking about of course, two cells make a battery. This is electrochemical, electrochemistry. Okay, two cells make up a battery. Okay, when we have, we have, apart from the Daniel cell, we have the Leclanche cell also. We have different cells, okay, that make up batteries. Now, the reaction that takes place in Daniel's cell is what? Is it a direct combination? Is it a redox reaction? Is it a double decomposition? Is it a neutralization reaction? Now, in the Daniel cell, usually we have the anode and we have the cathode in the cell. Now, what happens is that zinc is actually oxidized, okay, in Daniel cell. There are two elements that are involved. We have the zinc, okay, and then we have the what? The copper. Now, zinc will become oxidized, releasing electrons to do what? To now move, which will now move, in the current, which will now move in the circuit, will now move to what? To reduce the what? The copper ion that we have, and then reduce it to become a copper metal. Okay, in doing that, that is what happens generally in the world. Then said, let's look at the board and let's demonstrate what happens there. Okay, so we said at the anode, like I gave you one of our video lessons, we said that there's an acronym usually that I use, CARO, C-A-R-O, CARO. So which means at the cathode we have reduction taking place, at the anode we have oxidation taking place. So we are going to have first oxidation, have reaction. Okay, the equation first for oxidation have reaction, of course, that takes place at the anode. Oxidation takes place at the anode. Okay, so we have anode here. So what happens here? The zinc, okay, metal that's solid here, usually is going to become oxidized. Once it becomes oxidized, what happens is going to lose electrons. Okay, it loses electrons, that's 2 plus, then we have 2e minus. So the electron that it loses now will now continue to move in the circuit to the what? To the cathode, where the copper ion is actually reduced to copper what? Metal. So here we talk about the reduction have equation or reaction. Okay, of course, reduction usually will take place at the cathode. What happens here? We have copper. Okay, we have copper ion here. Okay, is going to become reduced. When it is reducing, what happens is what? It is gaining electrons. So the two electrons that were lost at this point of with zinc metal becomes what? Is now released here for this one to what? To become reduced, and then the electrons are gained at this point here. So what happens? We actually have the copper metal is being reduced. The copper ion is reduced to copper metal. This is copper or metal, that is solid. So we have oxidation taking place here, Daniel cell reaction. Then we have reduction taking place here. So what then is the overall cell reaction or equation? Okay, the cell reaction, overall cell reaction means that we want to add up this. Of course, we have we have 2 electrons here cancelling out 2 electrons at this point. So what do we have on the left hand side of the arrow? We have it. Then what we have on the right hand side, we bring them together. So overall we had this and this. So we are going to have zinc, okay, that's the metal here, plus copper ion, Cu2 plus, that's what we have on the left hand side. Then we have the arrow here. We have already cancelled out the number of electrons because we have 2 electrons here, cancels out. So on the right hand side we have zinc ion 2 plus, then plus copper metal sulfur here. So this is an example of a redox reaction. There is loss of electron, there is gain of electron. Remember, there is loss of electron, oil, and there is what? Gain of electron. Oxidation is loss of electron, while reduction is gain of electron. So let's move on. This is, of course, this is a redox reaction. Let's move on to the board, to the screen, and see what we have. Option A says direct combination. In Daniel's cell, that's not a direct combination. Option B says redox. Yes, redox, reduction and oxidation reaction. That is what actually happened there. Option C says double decomposition. No. Option D says neutralization. So the correct answer is option B, redox reaction. Now let's move on to question number 15. What happens when zinc rod is immersed in copper 2 tetrahydrosulfate 6 solution? Now, zinc is more reactive than copper in the reactivity series. So what happens first is, once the zinc rod is immersed into this solution, because zinc is more reactive than copper, the first thing that is going to do is what? It's going to displace this man here, because this guy here does not have power. It's not as reactive, okay, when compared to. So once it comes in first, this copper and tetrahydrosulfate 6 are married together as solution, okay? That's why they are able to form a solution. So when zinc, this is another man coming in here to meet this man. There's a man here, and then the tetrahydrosulfate 6 is actually the woman, okay? So when this man comes, he overpowers this copper and displaces the copper, and then comes in here to stay here. So once it stays here, copper is left alone. And don't forget that copper actually has a blue color of this solution before. This solution is actually blue because of the what? The presence of the copper salts that we have here. So once zinc comes in here, the zinc rod, it displaces this copper, and copper is off, then it attaches itself to this tetrahydrosulfate 6. So it becomes now zinc 2 tetrahydrosulfate 6. So the color of this blue that was initially in the solution will disappear. Okay, so we begin to form maybe a reddish brown coloration, okay, sort of, that is going to show that, oh, copper salt is no longer here. So that is actually what happens in this reaction. So option A, as you can see, says the blue color of the solution disappears. That, of course, is the answer, okay, because the copper ion, copper 2 ion has been what? Has been displaced by what? The zinc rod. The zinc comes in here and then forms what? Solution with this, comes in here and then it displaces it. So option B says electrons flow from copper to zinc. Option C says the zinc rod remain undissolved. Option D says the copper generates more copper ions. That's not going to happen. So what will happen here is that the blue color of the solution of the copper 2 tetrahydrosulfate 6 will disappear, because zinc rod has come in now to displace this copper 2 ion that we have there. So based on that, the correct answer is option A. Let's move on to question 16. We have C2H4, of course, that is your ethane, reacting with the hydrogen gas H2 to form C2H6. Okay, of course, this is an addition reaction because hydrogen is added to this to form this hydrogenation or whatever. So delta H is negative 137 kilojoules per mole. The question says the reaction represented above is what? Exothermic, spontaneous, endothermic, in equilibrium. Of course, this is an easy question. You don't need to waste your time on this. Remember, once you look at what delta H is, we just said that in one of the questions we saw. Once delta H, which is change in entropy, the amount of heat that is generated in that reaction that is needed for this reaction to take place. Okay, once you cover that it is negative, okay, it means that what? It is what? An exothermic reaction. So just go forward now and choose. It's not spontaneous, endothermic, it's not this. The correct answer here is option A, exothermic. Question number 17. How long means time, okay? how long would it take to deposit 0.08 gram of copper from copper chloride solution by passing a current of 0.5 ampere? Okay, we have copper, because this is a question under electrolysis, okay, which says that the mass, okay, of course, we talk about the first law, Faraday's law of electrolysis, then the second one of electrolysis is being played here. So what we are considering is the first law of electrolysis, of Faraday's law of electrolysis, which says that look at the relationship between the mass of a substance and then the quantity of electricity that is passing through that particular one, that is passing current around it to be able to generate that. So we are looking at the relationship between what the quantity of electricity in coulomb and then the mass of that particular substance. So the question says, how long will it take to deposit 0.08 grams? So the first thing we need to know first is what metal actually is going through electrolysis. Now we talked about depositing 0.08 gram of copper from copper chloride. So we need to write the dissociation reaction first of that copper. Okay, so we know that first copper ion, okay, 2+ here, becomes what? Reduced. Copper is reduced here from copper ion here to form what? To form a copper metal. Okay, this is a solid here. So which means we have 2 electrons here actually, because we have 2 electrons here. So that is going to affect the what? Number of what? Faraday. So if it were 1 electron, of course, it's equal to okay, 1 electron is equal to 1 mole, of course, times 1 Faraday. So if we have 2 electrons, it's going to be 2 electrons times 1 Faraday. Of course, this is going to still be equal to 1 Faraday. So 2 electrons times 1 Faraday, that is 2F. Okay, so which means that we have the quantity of electricity here by what? 2F. Okay, because we have 2 electrons here. 2F here, 2 Faraday actually deposited first. What is the mass of the copper metal now? The mass of the copper metal, it was given as 64. So we have it here as 64 gram of what? Copper metal. So this 2 Faraday, don't forget that 1 Faraday is actually equals to 96,500. So we are going to change this back from 2F. It's going to be 2 times Faraday becomes 96,500, so that it can be in what? In coulomb, because 96,500 a coulomb equals to 1 Faraday. Then we have 2 Faraday now. It means 2 times 96,500 to be in coulomb. So this is the quantity of electricity now that deposited, okay, to be able to form what? 64 gram of copper. Okay, now if 2 times 96,500 coulomb deposited 64 gram of copper, that's from this equation, from this reaction. Now the question says, how long will it take to deposit 0.08 gram of copper? 0.08 gram of copper. So we have to determine first what is the quantity of electricity first that is needed to what? Deposit 0.08. So we can have that here, 0.08 gram of what? Copper. I want to get what? The amount of electricity that will what? That will deposit, okay, that will deposit 0.08 gram of copper. Again, the relationship is between quantity of electricity and what? The mass, okay, according to Faraday's first law of electricity. So if this 2 times 96,500 coulomb deposited 64 gram of copper, how much of electricity will deposit 0.08 gram of copper? So what we just need to do is what? We just cross multiply. So by the time we cross multiply, what we'll be having is will be x times 6 will be 64 gram. 64x will be equal to 2 times 96,500. We are multiplying it to this times 0.08. Okay, so which means x will be equal to 2 times 96,500 times 0.08. So we divide all through by 64 because we want to make x the sort of formula. So by the time you solve all of this, punch all of this in your calculator and divide by 64, we are going to have 241.25. Of course, this is what? This is coulomb. This is coulomb. So this is what happens here, 241.25 coulomb. This is what? The mass of what is. But don't forget also, this is the quantity. So we say that the quantity of electricity, but don't forget that quantity of electricity is actually equal to what? IT. Okay? So quantity of resistivity is equal to IT. So if quantity is equal to IT, we were told already from the question that the amount of current that is passing through is actually 0.5 ampere. So if it is, then we can just say quantity of resistivity here, we got that already to be 241. So we replace that here as 241.25 will be equal to the current that is passing through is actually 0.5 then times t, because the question says we should find what, how long, which is what, the time. That's why we are bringing in this formula. How long means time. So once we have gotten the quantity of resistivity, now relate it with what, the IT. We are given the current, so this is 241.25. Of course, quantity, that's coulomb, equal to 0.5. So if we divide both sides by 0.5, divide by 0.5, we have this cancels this. So t will be equal to, if you divide this by 5, so it means that divided by half. So we are multiplying this by 2. Okay, so that should give us 2 by 25, that is 50, 50. 2 by this, that's 2. 2 times 4, that's 8. Then 2 times 2, that's 4. So we have 428, yes, 428.50, okay? But don't forget, this is what? In seconds, because that is the what? The unit that we have there. 482.50 seconds. If you look at the options we were given, you discover that the options we were given were actually in minutes, okay? We have 6 minutes, we have 8 minutes, we have 24 minutes, we have 48 minutes. So you can't leave your answer this way. So look for a way to convert this to what? To minutes, because the answer was not left in seconds, it was left in minutes. So if you convert this to minutes, so it means that definitely we know that 60 seconds make 1 minute. So it just means we are going to divide this 482.50 divided by what? 60, because 60 seconds make 1 minute. So by the time you divide this, of course, 6 can go in 48, that's around, that should be around 8, okay, point. Then you have this, you have this, so that will be 0 time, it can't go in it, 60 cannot go, we have 0, then we have maybe 4, 2, and so on and so forth. So approximately we have about 8 minutes is what we have here. So that's the time. How long? So it's going to take 8 minutes for 64 grams of copper to be deposited as what? To disintegrate into what? 0.08 gram of what? Of copper at that point. So let's look at the options we have on the screen. Option A says 6 minutes, option B says 8 minutes, 24 minutes, 48 minutes. So the correct answer is option B, 8 minutes. Question 18. Tartaric acid is used industrially to what? From our acid base and salt, okay, we're told that tartaric acid is actually an organic acid, okay. We get tartaric acid from grapes, from bananas, and some other fruits like that, okay. Usually tartaric acid has what we call a flavor that we call tart, okay. That's where the name came from, tart. It has a flavor that it gives. So because of that, it is used as an acidulant, okay, in food products. Like in food products industry, like we have carbonated drinks, we have tartaric acid added, we have them in jellies, okay, we have them added in wines. In fact, it is even used in making of what? Baking powder. It's even used in removing rust in the industries, okay. But we are looking at the major ones. So if you look at the options, we have make baking powder, yes, it is used in making baking powder in the industry. Make fruit juices, yes. Remove rust, yes, it can be used dry, so it's not used as drying substance, okay. But the major one, because tartaric acid is actually gotten from fruits, okay, gotten from fruit. We have other means by which we can get it, but from grapes, like I mentioned, from grapes, from bananas, we can make tartaric acid, and because of the flavor it has, it finds more application in the use of what? In carbonated drinks, like I said, in jellies, in wines, in making of what? Fruit juice. So because of that, so the best answer here we can go for is option B, make fruit juices. Question number 19. The salt formed from strong acid and strong base is what? Is it a complex salt? Is it a neutral salt? Is it basic salt? Is it acidic salt? Now, when strong acid reacts with a strong base, okay, usually we form salt and water. Of course, that's a neutralization reaction. Okay, so all this, because both of them are strong, no one is stronger than the other one, of course, the equation is going to be balanced. So which means that we are going to have a neutral salt is going to be fine. I think we should have an example of a kind of reaction that can take place between a strong acid and a strong base. Let's see the kind of salt we can have, then we'll come back to the option to pick the best option. So we have, talking about a strong acid, Give us an example of a strong acid. Of course, commonly we have ACl. Okay, so ACl is a strong acid. Reacting that with a strong base, any strong base of your choice. Let's choose sodium hydroxide is common. Okay, sodium hydroxide. Then we have, of course, this is a neutralization reaction. What happens? We are going to have sodium here together with this chloride ion to form chlorine. Yeah, sodium chloride. Then we have plus H and HO. We have what? H2O here. Okay, so this is the salt and this is the water. Of course, this salt would have been acidic if we had maybe hydrogen here in here together with this sodium. It would have been acidic. It would have been basic if after having this salt we have OH attached to it. Okay, it would have been basic. It would have been complex if maybe we have complex ion formation. We have this in brackets. Then we have maybe 2 raised power that. It would have been complex ion. We have more other elements or compound ions that are forming. It would have been complex ion, but this is neutral, okay, because there is actually no hydrogen here. All the hydrogen that is formed. So let's talk about neutral salts. Neutral salts are formed usually when all the hydrogen ion that is present in the acid has been replaced. All the hydrogen is replaced by what? A metallic ion. So the metallic ion here is sodium now. It has replaced all this hydrogen ion here, so we don't have any hydrogen left here. So whatever salt we have here is called a neutral salt. So let's move on to the screen. Option A says complex salt. It is not. Option B says neutral salt. Yes. Option C says basic is not basic because we don't have OH attached to that NaCl, and then acidic because we don't have hydrogen ion still remaining there. So the correct answer is option B, neutral. Do you have any question bothering your mind at all on all we have done so far? Please feel free to ask your question. All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to ask a question and then solutions will be provided within the shortest period of time. Now let's move on to question number 20. Dissolving some pellets of sodium hydroxide in water would result in what? Now, pellets of sodium hydroxide, don't forget that sodium hydroxide is a salt that actually undergoes deliquescence. When we talk about deliquescence, there are some salts, when you expose them to the atmosphere, what happens? They absorb moisture and then they turn into solution. If you get pellets of sodium hydroxide, put it on the surface, just on its own. After some time, you discover that what? Just a few minutes, it begins to what? To melt. You discover that until what? It turns into what? Solution. It has absorbed moisture in the atmosphere and it has turned into a solution. That is a deliquescent salt. Now, if you now pick this pellet salt now, or pellets of sodium hydroxide, and dissolve inside water, what happens? Number one, the ions will be what? Will be split, will be broken down. Breaking of the sodium ion, we have sodium ion, we've separated, hydroxyl ion, we also be what? We separated into different parts. So that is going to now lead to what we call a kind of randomness, okay, a degree of disorderliness, because we now have more ions now. We have more sodium ion, Na+, then we have the OH minus, more of that in the what? In the water. So that's going to cause a lot of random movement. It's going to cause a lot of disorderliness in the water, in the solution, okay? When we talk about randomness, the degree of, disorderliness in the system, we are talking about what? Entropy. Yes, entropy change is the what? The level of disorderliness of the particular system. So apart from that, now don't forget that dissolving some pellets of sodium hydroxide in water will mean that what? More heat will be given off. So when we have a reaction where more heat is given off, it is an exothermic reaction. So if it's exothermic reaction, more heat is being given off. As more heat are being given off into the environment, what happens? We discover that what? The level of what? Kinetic energy of the ions that are present will also increase. So once the level of the kinetic energy of those particles in the water begin to also increase, the randomness increases. So in other words, we are talking about what? The level of disorderliness also increases. So entropy change will also what? Will also increase. So let's look at what option. Now we understand what happens here in this reaction. Option A says a decrease in the free energy of the solution. If it were the free energy, of course, that we have there in the reaction, we are supposed to have an increase, not a decrease. Option B says a decrease in the entropy of the solution. With the explanation we just gave now, you agree with me that there's supposed to be an increase in the entropy change, the level, the degree of disorderliness, okay, in that system. In the system, definitely is going to increase because the randomness will increase. So it is not decrease, it should be what? An increase. Option C says a lowering of the temperature of the solution. Lowering of temperature of the solution. Of course, the temperature of the solution is not going to lower, it's going to increase because more heat will be what will be given off because the pellets of the sodium hydroxide on its own produces heat. So now introducing it into water, in fact, if you touch the vessel of that, you discover that it's going to become very hot. It will be very hot. If you touch the vessel, it will be very, very hot. So the temperature of the solution will not be lowered, it will be what? It will be increased, okay? So which is not so correct. Option D says an increase in the entropy of the solution. Of course, the level of disorderliness, the degree of disorderliness in that system will be increased. So based on that, option D is the correct answer. Do you have better explanation or better step to solve some of these questions we have solved? Please feel free to share with us. All you need to do is to go to the comment section, indicate the question number and the solution you wish to share. Now let's move on to question number 21. Calculate the number of moles of HCl present in 20 cm cube of a 0.75 molarity of solution of the acid. Okay, we want to find the number of moles. We're given the volume, we're given the concentration. I think this is easier, so let's just move to the board and do justice to that question. We're asked to find the number of moles, okay, of HCl. So we have that number of moles, this question mark unknown. We're given the volume, okay, to be equal to 20 cm cube, and then we're also given what? The concentration of that to be equal to what? 0.75 molarity. So sometimes you see capital letter M, sometimes you see mole per dm cube, okay? It's the same thing, okay? But in this question, we're given what? Capital letter M, molarity. So we have that. So we're asked to find number of moles. So there's a relationship actually between number of moles, volume, and then concentration. What is it? Number of moles is actually equal to concentration times volume on over 1000. Now we are bringing in 1000 as a conversion factor, conversion rate factor, because we know that the volume was given in what? Cm cube, okay? By default, it should be in what? Dm cube, 1 dm cube. So that's where we usually have what? Divided by 1000. But in case, in any question, if you are given the volume to be in dm cube, let's assume we have 2 dm cube or 2.0 dm cube or 1.5 dm cube, then you don't need to bring in this 1000. You just use n equals to what? Cv, okay? So that is just it. But whenever you see that the volume is in cm cube, so there must be what? Divided by what? 1000. So with number of moles, then will be equal to concentration is 0.75. We have it multiplied by the volume was given as 20, okay, divided by what? 1000. Of course, if you multiply 0.75 by 20, okay, we should have about that's about 15, I think. Yeah, that should be 15 divided by 1000. So if you divide this by 1000, you have 0.015. Yes, 0.015 mole. Yeah, that's what we have. That's what we should have. So the number of moles should be 0.015 mole. Let's look at the options we have from the screen. On the screen, option A says 0.015. So the correct answer is option A, 0.015 mole. Now let's move on to question number 22. The oxidation state of oxygen in tetraoxosulfate 6 acid is what? Oxygen in tetraoxosulfate. So let's move to the board and calculate. Don't forget that tetraoxosulfate 6 acid is H2SO4. So we have H2SO4. That's the sulfuric acid. What one of the laws or the rules in calculation of oxidation state, oxidation number state, is that what? The sum of the compound, okay, the compound in its free state is actually equal to 0, okay? So we are going to equate this. This is the compound now. It is not ionic, so it is equal to what? To 0. Okay, so now, also we know that the oxidation state, what to calculate the oxidation state of what? Of oxygen is what we want to calculate here, okay? So we know that hydrogen is actually positive 1. It has a valency of 1, okay? So that would be, so we are going to have, this is what we have is oxidation number of hydrogen here, okay, because we have 2 of it, so we have times 2 here, plus Oxidation number of, I'll write ON of sulfur here. Okay, sulfur does not have any this. Then we have plus oxidation number of oxygen here. Okay, oxygen here. But we have 4 moles of that, so we have times what? Times 4 here. So this will be equal to what? To 0. Okay, so this is what we are going to battle with. So we have 2 times oxidation number of hydrogen is actually positive 1 plus 1. Then we have plus oxidation number of sulfur, of course. We call it is 4 because we call it hydrogen tetraoxosulfate 6. Okay, that's 6 actually, not 4. That's 6. Okay, so we call it that. You call it sulfur 4 oxide. So that you call it tetraoxosulfate 6 acid, or you call it hydrogen tetraoxosulfate 6. So if you are calling the hydrogen, then you don't need to add acid at the end of this. Just call it hydrogen tetraoxosulfate 6, or you call it tetraoxosulfate 6 acid. So sulfate 6. So which means the oxidation state of sulfur is 6. Okay, that's how we have it, sulfate 6. So we have oxidation number of this is already positive 6 plus 6. Then we have it plus oxidation number of oxygen we don't know. So we can say that is X, then times 4. So we say that is 4X. Because that's what we want to find, equal to what? To 0. So that's plus 2 positive plus 6 positive 4x, so this is equal to 0. So we have this is positive 8 positive 4x is equal to 0. So we have 4x here. We transfer plus 8 to the other side, it becomes negative 8. Okay, so divide both side by 4, divide both side by 4, 4 cancels 4 here, so x will be equal to 4 goes here, 1 is 2, so that is negative 2. So the oxidation state, oxidation number of oxygen in tetraoxosulfate 6 is actually what? Negative 2. So if you look at the option we're giving, option A is minus 4, option B is minus 2, plus 4 plus. So the correct answer here is option B, negative 2. Question 23. MnO2 react with XaCl plus this to give this and this. So in the question above, what are the values of X, Y, and Z respectively? Okay, so what the examiner just expects of you to do is to balance up that chemical equation, that reaction. Once you balance it, then you substitute what the value of X is, what the value of Y is, and then what the value of Z is. Let's move on to the board so that we can see that we have the equation written out already. Okay, so what I'll just do is I'll clean up this. Okay, okay, let's leave it there. So what we'll just do is I will just balance it by putting the values underneath so that we can. So we have manganese, 1 is here. We have 1 manganese on the right hand, is balanced. Oxygen, 2 moles of oxygen here. We have 1 mole of oxygen on that side. Okay, so this 2 is what we have here. We have 1 here, so we can change, actually put 2 here. Okay, let's put 2 here. Let me put Y underneath here. Then let me put X here so that we know what it is. So we don't, this is Z for this. So this is 2, we put 2 here. So we check again. Manganese is 1, manganese is 1, that's balanced. Oxygen is 2 moles here on the left hand side. Oxygen on the right hand side is also 2 moles, that is balanced. Then hydrogen here, let's look at hydrogen. Hydrogen here is 1. Hydrogen here now is 2 times 2, that is 4 moles of hydrogen. So here is just 1. So we can bring in 4 here, okay, to balance up that. So I think we are almost done. So we have, let's go back again. Manganese is 1 mole of manganese here, that's correct. Then we have oxygen is 2 moles here. We have oxygen here, 2 moles, that is balanced. Hydrogen is 4 moles here. Here is 2 times 2, that's also 4 moles, that's balanced. Then chlorine now, it is 4. Then chlorine here, we have 2 moles here. Then we have 2 moles here, which is also 4. So this means the equation is balanced. So that means this one is just what? It's just 1. Okay? So which means from what we just did now, X is actually 4. Then Y is actually what? Is 2. And then we have Z, which Z is actually 1. So it is in ratio 4 to 1, respectively. 4 to 1. So let's look at the options we have on the screen. So we look at the one that best fits in. 2, 1, 2, no. 4, 1, 2, no. 4, 2, 1, yes. That's option C, then 1 to 1. So the correct answer is option C, 4 to 1. Question number 24. Calculate the mass of chlorine gas which occupies a volume of 1.12 dm cube at standard temperature pressure. We're given The atomic mass of chlorine to be 35.5, molar volume of gas at STP to be 22.4 dm³. So calculate the mass of chlorine gas which occupies a volume of 1.12 dm³. So let's move on to the board and let's see how to attempt that question. Calculate the mass of chlorine gas. So we'll write here, calculate the mass of chlorine gas. So I will write that question mark. That's what we're asked to find, which occupies a volume of 1.12 dm³. So volume is 1.12 dm³. Like usually I tell my minders and the students to ensure that they write out the parameters that are given in every calculation question, whether it is in maths, whether it's in chemistry, whether it's in physics, or whether it's whatever value you are given in a question. Write out the parameters as is given and what is unknown that you're about to find. Then you now look at the relationship between the parameters you are given and what you want to find. There will be a connection between that. That will help you to get the calculation question so easily. So the volume we're given 1.12 dm³, and then what else are we given? We're given the relative atomic mass of chlorine. So I'll write that here, chlorine to be 35.5, okay, and then we're given the molar volume of gas at STP. Of course, that is actually constant, okay, for all gases. They have the molar volume at STP to be 22.4 dm³. Good enough. Both of them are actually in what? In the same unit. So the question says we should find what? The mass. To start with, do we have any relationship between mass and volume? Okay. Not really. Okay. Then we have volume and molar volume. Yes, there's a relationship between them. Volume and molar volume, the relationship between them is what? Number of moles. So if we get number of moles using volume and molar volume, then I think we can get our mass, because we have the what? The molar mass of chlorine given already. Then if we get the number of moles, we can get molar mass. Here is what I mean. So first, let's start with this. The known usually is what you use in getting what? The unknown. So we know that volume and molar volume has a relationship, which is what? Number of moles of gases, of particles, is usually equals to what? Volume over molar volume. Of course, molar volume is a constant that's always given to be 22.4. So which means number of mole will be equals to volume is given as 1.12 divided by molar volume is what? 22.4 dm³. Okay, so we have that happening here, 22.4. So this will be equal to, let's see how to solve this question. We don't have a calculator here. 1, 2. If I move it twice, that will be 1, 1, 2. 1, 2. Then I move this one also. 1, 2. That will be 2, 2, 4, 0. Okay. 1, 1, 2. I think 1, 1, 2 here can go here. 1, 1, 2, 1, 1, 2. That's 4, 2, 2. Okay. So that means here 1, here that's 2. That's 0. So that's 1 over 20. Okay. 1 over 20 is the same as 0 point. Had the 0 here. That is 0. 0 point we had this here. That's 0. Had 10. That's 0. Then we had 0. That's 5. So 0 point. So that's 0.05. So number of moles of this will be 0.05 what? Mole. Now that we have the number of mole to be 0.05 mole, and we know that between number of moles and then the mass, we have a relationship also. So number of moles of a substance is also equal to what? Mass over what? Molar mass. And don't forget, we are talking about the mass of what? Of chlorine gas. So that is what? Of chlorine gas that is formed. So we have number of moles already to be 0.5. So we have 0.05 here will be equal to the mass, which is unknown, that we don't have, divided by the molar mass of chlorine gas. Don't forget, chlorine gas, okay, is actually diatomic. So even though the mass is given as 35.5, chlorine molecule is always written as Cl2. So you cannot just use 35.5. So you are going to have 35.5 multiplied by 2, because it's 2 of that. So that gives us 71. So you are using this. Please take note. Don't use, many students will just bring in 35.5 as the mass of chlorine here. If you solve it, of course, you will still get an answer that is there, and then you will pick it and thinking that you have the correct answer. So please, whenever you are dealing with gases, if it is oxygen, the mass of oxygen gas, you want to, oxygen is 16. So if it is O2, as a diatomic, it becomes 16 times 2. That gives 32. So for chlorine gas is Cl2, which is 35.5 times 2. So that gives us what? 71. So in place of the molar mass of chlorine at gas, we have what? Chloride gas, we have what? 71, not 35.5, because multiplied by 2. So which means the mass will be equal to 0.05 multiplied by 71. Of course, this should give us, this is like half of that. That gives us 35.5 by 0.1. So that gives us 3.55. Yes, 3.55 gram is going to be the mass. So the mass of chlorine gas that produces what? 3.55 gram. Let's look at the screen. The option what we have there is just around C. So yes, that's C. 3.55 gram is the correct answer. So the correct answer is option C. Now question number 25. Which experiment led to the measurement of the charge on an electron? Don't forget that Millikan, of course, in the year 1909 with another scientist, that is Fletcher by name, okay, actually conducted an oil drop experiment in order to determine the charge on what? An electron. They came out to say that actually that if electrons are made from atoms, okay, of course that they are subatomic particles, they should be able to what? Quantify and to determine the charge that is present on electron. So they were able to come up with their oil drop experiment that, oh, the charge of electron is actually negative, -1, because they discovered that there was an attraction, okay, between the oil drop, which means that they are what? They are negatively charged, and they're able to say, okay, electrons are actually, you know, around them. So which means that for there to have been an attraction between the oil droplet means that there was what? They actually what? Unlike type, because unlike charges actually what? Will attract. So which means they are what? Negatively charged. So they came up with that with their oil drop experiment that the charge on an electron is actually -1. So the question says, which experiment led to the measurement of the charge on an electron? It is not the mass spectrometer metric experiment. It's not the scattering alpha particles. Okay, of course that was by Bohr. Okay, Rutherford. Then we have a discharge tube experiment. So which is not. So the correct answer is option B, oil drop experiment. I believe you enjoyed this content because I really did. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.